This segment is an introduction to the operation of the Pocket A3. Pocket A3 does three modalities: EEG, PIR, HEG, and NIR, HEG. Holding the right button down will start the device, and if you don't hit the start button immediately, it will go into a user guide which will indicate the function of the buttons. Here we see the left button is the scroll button and the right button is the select button. The right button can also be used to select menus, and the left button can do some added functions such as freezing the display. Pressing both buttons logs current system variables for later retrieval. This indicates where the connectors are for the three modes: PIR, HEG, EEG, and NIR, HEG. Headphones plugged into the top, and the device is wireless. Okay, this indicates that the battery is full, and we hit the right button to start, and we go into the main menu. The main menu are the items on the left: preset, mode, display, protocol, reward, sequence for binaural beats, and more pulls up an additional sub-menu, and go, which is to put it into the operational mode. Preset, we hit the right button, we can scroll through various presets. These first ones, PIR, HEG, NIR, HEG, to the PC. They are default wireless configurations. Just select these presets and hit go, and you should be able to communicate with your application running on the PC. There are also user presets, user 1, 2, and 3. You define the configuration you wish, save that, and thereafter just access them via the presets. And there are other preset modes which are particular protocols and test configurations. Note that for most of those presets, wireless may be turned off because they're intended for standalone use. Let's look at the More sub-menu. First item in the More sub-menu is the wireless. You can configure the wireless on or off. But let's first look at the contrast at the bottom there. This will adjust the contrast of the screen. Pressing the left button scrolls, pressing the right button selects, and then we can use the left button to scroll down. If we scroll again, it will scroll in the reverse direction, scroll up to set the contrast of the screen. Right button to select. Similarly for volume, left button to scroll down, and if you let it go and scroll again, it will go back up. Right button to select. User presets. This is in fact you have to explicitly save the settings for the unit to remember it as a user preset. Here you choose which you wish: user 1, user 2, or user 3 preset. You can also set the clock in the unit. The clock is used by when logging values. It logs a particular date and time, and there's also an alarm function for the binaural beat to turn it on and off. Wireless. Wireless is off. Wireless is raw to PC, which is the most common mode. RF to raw, which is the unit can receive signals from other units. Protocol to PC, which is the output of the protocol filters going to the PC. And this too is where you change the RF channel number. Currently it's on the default RF channel 1. By selecting it and then scrolling with the left button, we can choose another channel, such as channel 3. It will then broadcast that information to a wireless dongle, any wireless dongle listening on the previous channel, and change that automatically. Okay, this line here has many functions multiplexed, including what type of NIR, one channel or two channel, whether you're using the internal noise generation, whether there is automatic level control on or off, whether the EEG signal bandwidth is 40, 48 or 56 Hz, whether the anti-pinking to level the EEG signal is on or off to send to the PC please, and then whether lock is on or off. Lock is to inhibit some of the functions from access by the final user. And firstly we have here whether it's one channel operation for EEG, whether it's differential operation for EEG, or whether it's two channel operation. It can also be a test configuration to test for 50-60 Hz interference, and it's also the function where you can upload new firmware, which we'll get to later on. Okay, having selected a preset, it's simply a matter of hitting go, and the unit will start transmitting if the wireless is on, or it can be used in standalone mode through displays such as this, or with the headphones plugged in. For standalone mode, the presumption is that the headphones are switched on. Okay, let's now have a look at some of the displays available. Halley's display. This is a reference to Halley's Comet, but it's a game of Pong, where the bats at each end of the unit are controlled by the protocol. Whether you're successfully satisfying the protocol or not will vary the size of the bats. And if it's a two-channel protocol, the left and right will operate independently. And the unit keeps score, so it's basically the left hemisphere playing the right hemisphere in a game of Pong. There, the left hemisphere lost and the ball scraped through. Okay, next is the binaural beat display. This tells you what binaural beat you're currently hearing in the earphones. In the left of the screen you can see the number 112, and the right of the screen you can see 108. They're actually the frequencies in hertz being presented to the left ear and the right ear. And top center we can see 3 and now 2.9. That is in fact the beat frequency, the difference between those two frequencies, the binaural beat, if you like. Now you can see the flashing triangle. It's currently on segment 1. We've got T, B, M and D for tone or carrier frequency, beat, masking noise, and D for duration. So this first segment is going for 3 minutes. D equals 3. And after 3 minutes it will progress to the next one. Now they're all programmable through the sequence display. Okay, in this display here we get a slow time map of how the protocol is being satisfied or not by the amplitude of the signal you see in the screen scrolling across. You can see in the top left the actual protocol in force at the moment is a ratio of beta to theta, and it's mapping progress. There are two. Left button will change it from a fast scroll to a slow scroll, so in fact you can get a 10-minute history here. Next display is the probes, which gives you in the time domain the real-time EEG signal. Now this is in fact the internally generated noise or pseudo EEG signal that we're looking at. We'll note in the top center of the screen we have 1.1 volts. That in fact is a measure of the electrode offset potential. It should not vary between plus 2.5 and minus 2.5, and if it does you'll get a flat line. So if you have some doubts about the hygiene of the electrodes, you can check the offset voltage there. Next one is frequency, where we're looking at the EEG signal in the frequency domain. Again, we say that this is the internally generated white noise signal, so it looks relatively flat across the band all the way out to gamma. But we can see down the bottom there we have 10 Hz, 20 Hz, 30 Hz, and the relative amplitude of the various components of the signal. Next display is the mirror display, where the frequency axis is this time put on the vertical axis, and so we can see down the bottom we have gamma stretching up to the top of the screen. At the bottom we have delta stretching up to the top of the screen with gamma. We're only seeing the left side of the display because this is a one-channel protocol, so channel 1 is nominally the left hemisphere. If we had a two-channel configuration, then of course we'd be getting both left and right hemispheres. And we can see the white line, the dynamically varying white line, is the long-term average. And because this is white noise, it's appropriate that this looks relatively flat. Next display is the targets display, where here as you exceed the threshold value, you in fact increment a counter. We can see the counter going 22. Should increment shortly 20 to 30, etc. So it accumulates over a period of time. The period of time is set in the top left-hand corner, and that was 3 minutes. Next display, in fact, we can set a synchrony display to get 2 more. We've got a synchrony display here. It in fact has a trace of the complex correlation coefficient of channel 1 and channel 2 in the selected band. and it's in fact tracing out the pattern. If it's low correlation, the pattern will remain in the center of the head, but if there is good correlation, it will deviate out away from the center, and the location away from the center will be the phase angle of the correlation coefficient. So it's a complex correlation coefficient. The other display available in synchrony protocols is the Sahmadi display, where again the degree of synchrony this time is reflected in the facial expression. As the eyes squint more, the level of synchrony is higher. Okay, protocol. To set a synchrony protocol, there are 8 filters available, but for synchrony all filters need to be chosen to be the same band. Here we can see that they're all chosen to be alpha, and that is alpha synchrony. There is gain available in some modes, threshold for the A channel filters, threshold for the B channel filters, smoothing, the time constant for the feedback variable, and artifact. The unit in fact detects EMG, and you can set the threshold for EMG artifact inhibiting the reward. Protocol A has a total of 4 filters. You can see there's an up arrow, a down arrow, an up arrow, a down arrow, so that they can be configured as reward and inhibit, or as a ratio. And in fact, whether all filters bear on a channel or only part of them depends on whether it's 1 channel or 2 channel. For 1 channel protocols, all 8 filters are available to act on that 1 channel. If it's a 2 channel protocol, then there are 4 channels available on each protocol. Rewards when in standalone mode through the headsets, we have a choice of chimes, chords, upticks, which reward only if the threshold is exceeded, a continuous tone feedback, and uptone, again a tone, but only if the threshold is exceeded, or no rewards. The sequence main menu is for programming the binaural beat sequencer. We can see that we have you can program the carrier tone, the beat frequency, the level left and right, the masking white noise, or pink noise actually, the duration of each segment, and there are 8 segments in all. And there's also one user programmable carrier frequency, currently set at 880 Hz, and one user programmable beat frequency, currently set at 6.8 Hz. They can be varied and remembered by the unit. Okay, and hit the go, and the unit is now operational. Wireless is on, it's transmitting to the PC. If not, it's used locally. Right, so let's look at the capability to program new firmware into the Pocket. To do this, we can use the BioExplorer software. We go into BioExplorer's device manager, but note that only the Pendant EEG device manager has this capability. You would normally use the Pocket A3 driver with the Pocket A3, but to in fact reprogram the firmware, you'll need to choose the Pendant EEG driver, and we can see that it has a particular tab called Pendant, which includes a few extra capabilities, including uploading new firmware. As we can see here, it's simply a matter of selecting the file which you have downloaded from our website, which is the latest version of the firmware for the Pocket A3, and the file will execute. Thus, you'll see the firmware scrolling through the display window. It takes in fact several minutes to download firmware to the Pocket A3. If the download is successful, the A3 will reboot and the new version will be displayed on the screen. If it's not successful, it will sit there waiting for another attempt to upload the firmware. Okay, thanks for your attention.